Hey guys, welcome to Bliss Robotronics. What you see on my table is, as you already know, the robot controller M1 module. And apart from the module here, we also have several accessories, I would say. So one is the USB to mini USB cable. So we'd be using this cable either to power up the board or to program the controller on this particular board. And we also have RMC 2-pin RMC connector here. So we'll be using this cable to power this particular board using external power supply. So also is 9-volt battery connector. So we have a 9-volt battery here, which we would be plugging to this battery, and we would be using these terminals to connect one end of this particular connector here to power this particular board with external supply. So that's the whole idea of these three accessories that you are seeing here. And so what we would like to cover in this particular video is to show you how you could use this particular board to interface devices like motors and sensors, and probably how you can program this particular board. So we'll be covering all these topics one by one. Now let's start off with the introduction about this board. As you already know, we had a review video a few days back which was explaining each and every part on this particular board, so I wouldn't go in detail about that. And the main thing that I would like to show you is the connector here. So we have a jumper down here, so we will be using this jumper to switch between the power supply, whether we want to use our external power supply or we would use the USB power supply. So I'll leave it in the initial position, that is the second pin and the third pin being shorted. So this means that we would be using the supply from the USB. Okay, I would like to quickly help you make a particular connector which would help you use external power supply with this board. So what you would need for this is RMC connector like this. So this would be included in the kit when you buy this board, so you need not worry about what kind of a connector you would want to use. So this would be there in the kit and you can use it as is. And also along with that we have this particular connector here. So we would be using this connector to hook on the 9-volt external power supply. So that's about this particular connectors here. So you can watch this video to see how I would turn this two different wires into power supply connection for this particular board. So I would quickly have my wires stripped off these particular cable. So there you see there's a brown wire and there's a black wire. So brown wire would represent my 5 volts and or the positive supply, and the black wire here would represent the ground or the neutral. So same way on the other side we have the positive cable which is for the positive supply, and the black wire for the neutral supply. So I'm gonna quickly twist them around. Okay, before I do that, I have these heat shrink tubes. So this I would be using to make sure my soldered parts are secured in its place. So I would include these heat shrink tubes also in the kit. So once you're using, you can pick it from your kit and you can use it. So what I'm doing is I've just inserted these two heat shrink tubes into these connecting wires here, and I would twist the brown wire with the red wire and the black wire with the other black wire. I don't know if you can see me doing that. So I have the cables well twisted and I would solder these wires in place. Okay, let me just see that. So I have my soldering wire here. So I've secured these two cables in its place. So what I would do is gently pull this along so that this is in line with the wire, and I would do the same on the other one too. So my connection should look like this. So once I have the connection in place, what I would do is I would cover the soldered part with the heat shrink tube, and with that I would gently heat the tubes with my, so this would shrink the tubes in its place, securing the two soldered connection that we have. So you would notice the tubes shrinking down to a smaller size. You just need to heat it. You can do it either with your soldering wire, or you can simply use a matchstick or your lighter to do what I'm doing right now. So once I do this, the soldered wire is in place, and the heat shrink tubes are shrunk, and now they will be securing this particular cable in place. So I'll be using this particular cable to power up the robot controller board with this 9-volt battery. Okay, so that's okay. We have covered up one part of it, and you're seeing a small connector down here. So this was nothing, just to indicate that the two analog inputs that we have down here. So I would be providing one connector similar to this. So this particular connector has a 4-pin. So instead of 4-pin, I would be having the 3-pin connector, which would be lying down here, and I'll be providing a cable similar to this with three wires in it, and you can plug in and you can use your analog sensors directly without any issues. So we have the cable secured. So let's just try it out and see if the board powers up with this particular external supply. So there's a plastic sheet on this particular battery. So this is a very cheap 9-volt battery that I have with me here. So you also get a rechargeable version of it, so you can use these kind of batteries for your particular projects, and that would save you a lot of money and also space. So since it's small enough to fit in, it goes into its place and secures up and makes your connection and your robot look pretty neat. Apart from that, what you can also use is a battery pack like this. So you can have 6 different AA size batteries. So you can either use an alkaline battery or a zinc carbon battery, or even nickel metal hydride rechargeable batteries like the ones that you're seeing down here. So you would be having a connection similar to this. So here, in case instead of connecting this particular so if you're planning to use a battery pack like this, instead of connecting this particular connector to this RMC connector, what you can do is you can simply connect this particular cable to these two cables from this battery pack. So that would that's an alternative that you have. So what I wanted to show, so you can use a battery pack like this or like that, or also available in the market is lithium-ion battery pack. So you can use a 7.4 volt battery pack. So you either get it in 3.7 and 7.4. The next one would be 7.4 with a 2-cell lithium-ion battery. You can either use that, or you can use a 9-volt battery pack like this, or the other one that I showed you. So the battery choice is totally up to you. You can pick and choose whichever battery you want. All that you need to make sure is you're providing supply to this particular board, which is a bit above 6 volts. So 6 volts is the minimum recommended voltage. So I would prefer you use somewhere about 7 to 9 volts, so that this particular board gives its maximum performance. Okay, so let's quickly connect it up. So I have my So I have this battery connector connected to the battery, and now have the other terminal. So you would wonder where you would be connecting this particular connector. So if you bring the robot controller close, if you look at this closely, you see a marking which says battery, which is BATT, and says 6 volts to 9 volts. So this is your battery connector, and you would be connecting your battery down here. So I would simply plug in. So this, you need not be worrying about the interchange in the polarity, because there's already a polarity. I don't know, I can say that there's already a circuitry inside which would save your board by wrong connections. Just that it wouldn't work when you connect your battery pack in the wrong direction. So it gives an indication that you have connected it wrong. But apart from that, I also have this particular connected. So this particular connector that you see down here, so you can always plug this particular connector in one direction. So you cannot change your direction while you're plugging in. So you just make sure when you're trying to plug in and the connector is not going through, that means you're connecting it the wrong way. So here, if you see down closely, there is a notch, there's a ridge here through which this particular plastic slides in and holds this particular connector in place. So I would just plug it in there like that. Okay, so you saw that you saw the LED glow. So now I've just switched it off. I will switch it on, and you see this LED glow, which indicates that your power supply is working and your voltage regulator is doing its job. But this microcontroller wouldn't work as such, because yes, as you already guessed, the connector jumper down here, we had set it to use this board with a USB power supply. So what I need to do is I need to plug this particular board in the first two positions like this, and you would see the board is now powered with the external battery source. So I already have a program written inside which would glow these LEDs D5 and D3. So you can see, so this you can ensure that your board is working fine now. So you have your board powered up with just the external battery, and this works fine. So you have your battery powered up, you have your board powered up, and you have it set ready to use. Okay, that being one part, I would show you how you can prepare your motors to connect to be interfaced to this particular board. So for my projects, I would prefer using motors like these. These are called BO motors. So these are geared motors which are driven by these DC motors that you see here. So these are pretty tiny and pretty cheap, and would look neat on your robotic project, since it's the size is pretty small, and the wheels can fit in pretty easily. So what I've done is I've used, as you saw the connector that we use, I had another connector like this. So this also would be provided. So in the kit which you buy, you would be getting 3 such connectors. So one would be for your power supply and 2 would be for your motors. So I have soldered this particular cable in its place. So there's nothing to worry about the polarity. So just that you just do it trial and error method. So you just solder it in one direction and see if the motor rotates in your preferable direction. If not, just either you can change the polarity or you can change the code in your microcontroller to drive this particular motor in a specific direction. So again, so I have 2 such motors here to show you how we can interface 2 such motors to this particular robot controller board. So this robot controller boards can drive 2 DC motors simultaneously with the help of this L293. So looking at the connector, same principle here. You have a ridge down the cable, ridge in the connector, and that connector just slides through and snaps in its place. So when you have the connector plugged properly in its place, it's the connector is secured and it won't easily come off. So I do the same thing for the other motor also. So same policy, ridge on the connector, I slide it down and it gets snapped in its place. So these cables wouldn't come off easily unless you apply a lot of force on it. The connectors down that I've used here is pretty old, and there is a small notch in between these 2 ridges. I don't know if you can notice on the camera. So this is what will help you hold will help this particular connector be held in its place. So once you snap it, that particular small ridge that you saw will hold these two connectors together. So you don't have to worry about the connectors sliding off from its place. So you have a very secure connection. So the three basic connections that you would need for your robot controller: so your power supply and your two DC motors. As I already told you, I have programmed this particular board. To drive two DC motors, and we would see how this particular program works. So I have switched on the power supply, and you would notice that there is no noise. Okay, so you'd be wondering why aren't the motors running. Very simple, very basic idea. When we were doing the review, we just noticed that we do have a switch which helps us save energy just by turning off this particular device when we don't want to run the motors. So I would need to turn on the second switch down here. So second switch is for enabling or disabling your motor driver circuit, and when I slide it to position 2, when I slide the switch 2 on, so I'm enabling this particular motor driver circuit. So let me just turn it on and show you what happens. So I don't know if you can notice the motors are spinning. So the program that I've written here is to spin the motors in every possible direction. So as you see the LED change its blinking status, you would notice change in the direction of the motors. So that spins for some time, and then the controllers change the directions. So what I'll do now is I would connect wheels to these particular motors, just to show you how well these particular robots spin. So I'll just turn off this particular device to save the juice in this battery for the rest of my video. So again, for these motors, the wheels are you get specific type of wheels. So what I mean by specificity is that when you look closely, the shaft where you would connect your particular motor, it's not a circular shaft, but instead it looks something like this. So I don't know if you can notice in the camera, this is not circular, it's circular on two sides and flat on the other two sides. So how this would help is that when it slides into this, even if it's not secured, the wheel wouldn't spin without the motor spinning. Okay, so the motor spins with the wheel. So also on the other side you have a small screw which would help you keep the motors in its position. So I will quickly fix these two motors, and yeah, I have them in place. And now I will turn on the robot controller board to show you how the robot spin. So there you see the motors are spinning, and you would notice there would be a change in its direction after 5 seconds or so. I don't remember the timing that I had set. So all that we have now is a robot controller board, a battery, and two motors, which is controlling our robot. So this is the simplest setup that we can have for our robots. So I could see I'll show you how I can disable the motor driving circuit instantaneously. I just turned it off, but the LED is still running with blinking, which says that the microcontroller is working, but just that it is not driving the motors. I would turn it on. Okay, the motors are not spinning right now. Okay, they started spinning. So there's not enough juice from this baby to run that particular motors. Okay, that's how you instantaneously turn on or turn off your motors. So we can write a program and program this particular microcontroller to see the changes in direction of this particular motors. So we would be looking at it probably in our next video. So this is how you would connect your peripherals to the robot controller board. Very basic connections, just 3 connectors that you need to have. So just prepare your battery connector in place, and you can solder them, and once you solder, snap it, and so your cable for supplying external for powering this particular board with external power supply is ready. And apart from that, you will have 2 more cables, which once you snap it with your motors, with your DC motors, you can snap them again to this particular board, and voila, you have your own robot controller board with which you can control your motors. So very basic connection that we saw, importance of this jumper and importance of this particular connector, of this particular switch down here. And you saw the motor spinning in one particular direction. We can write a program to spin the motors in as many directions as we want. So this was the end of the video. We would in our next video we will see the same setup, with just that we would be powering this particular board with the USB connection, so we won't have our battery down here to run these motors, and we would see that in the next video. Thank you guys, thanks for watching.